Okay, I've been asked about, these questions, but also question 8. But if I go through these two, question 8's just a Pythagoras one, so you should be able to work it out from there. Okay, but I'm going to go through these two. We will need a calculator with these because it's going to involve trigonometry and Pythagoras' theorem. So for the first bit, we've been asked basically to work out how high it went. This 6-meter ladder went up the wall. So to start off with, we need to label our sides. Remember, opposite the right angle is the hypotenuse. The adjacent goes between the angle and the right angle, so that's the adjacent. The other one's the opposite. Now in this question, because I've been asked how far up the wall it goes, I'm after the adjacent. Okay? So, because that's between the angle and the right angle. I'm given the hypotenuse, so I'm not really interested in the opposite. So for A, I would start by writing down, remember saw, ca, toa? Well, we don't want something involving the opposite. That one involves the opposite, that one involves the opposite. So we're left with ca. Remember how we worked this one out? We're basically wanting to find the adjacent, so we cover up the adjacent. So the adjacent C times H, so it's cos, always of an angle, so in this case 34 degrees, yeah, times the hypotenuse, which is 6. So if I work that out, turn it on, okay, so we want cos 34, don't forget to close your bracket, times 6 gives me 4.97. Okay, 4.97 to 2 decimal places. Okay. Now for the second bit, they've asked me to work out the opposite here. Okay, now I could do that in one of two ways. I'll change colour to work out this bit. Okay, we now want to work out what this side is. I could either go back to here and use SOHCAHTOA again. This time I'm not interested in the adjacent, so it's opposite and hypotenuse, which is sine, or, which is how I'm going to do it, remember if you've got two sides of a right angled triangle, you can always use Pythagoras' theorem. So we know 6 squared equals, that's the longest side squared, the other two sides added. Now we know the adjacent is 4.97 plus what we want to work out, which is the opposite squared. Okay, it's not 0, that's O for opposite. Okay, so the opposite squared is going to be 6 squared, take away 4.97 squared. So the opposite will just be the square root of that. And if I work that out, we've got square root of 6 squared minus 4.97 squared. If I work that out, it gives me 3.36 meters. Okay, so that's using SOHCAHTOA and then using Pythagoras' theorem. Going to do a similar thing here. This time though, with question 9, it's asked me to work out an angle. Now it should always remember that if we're doing trigonometry, if it's an angle we're after, remember at the last step is we work out the inverse sine or the inverse cos or the inverse tan. Now here if I look at it, remember that's the right angle, that's the hypotenuse, that's the adjacent. Again, we're not really interested in the first bit. Okay, we're not really interested in the opposite. So if I think of SOHCAHTOA, remember the bits that involve the opposite are those two bits there. We don't want them. So it's this one. Now, I'm after the angle here. If I'm after the angle, it's the cos I'm going to work out first. So I know the cos of this angle, x, is equal to the adjacent divided by the hypotenuse, which is 15 divided by 28. Remember, I can write that as a fraction, okay? But I don't want the cos of the angle, I want the angle. And remember, if we're working out the angle, it's got to be the inverse. So that would be the inverse cos of 15 divided by 28. Now, if you've got a scientific calculator, you can just plug it in just like that. Look at it. I can use the fraction button. So I'm going to do inverse, remember, is shift. So it's shift cos to give me the inverse. So shift cos. Remember, it's always shift if you're working out an angle. And use the fraction button. We had what? 15 over 28. Close the brackets. Check my calculator's in degrees, because otherwise that'd be a bit annoying. It is. And it gives me 57.6 degrees. Okay, so 57.6 degrees. Now for the next bit, again I'll work in blue for this, it says how high. I could either use trigonometry, but I think it's easier to use Pythagoras' theorem. If you're given two sides of a right angled triangle, you can always work out the third. Yeah? So longest side squared, which is 28 squared, is equal to the two shorter sides, 15 squared, and again it's the opposite squared here. Yeah? So the opposite squared is going to be 28 squared minus 15 squared. So the opposite will be the square root of that lot. 28 squared minus 15 squared. At this point, I reach for my trusty calculator again. And we do that. So cancel everything. Do the square root. And it's 28 squared. Use my squared button. Minus 15 squared equals. And it tells me root 559, which is not terribly helpful because I want a decimal. So I'm going to use the S to D button, turns it into a decimal. So it's 23.6 to 1 decimal place. And what was it in meters? Okay, so you can say the kite, or wherever it was 23.6 meters up the tree. Okay. So that's how you do them. Remember, Pythagoras' theorem, longest side equals the other two sides squared and added. So if you've got two sides of a right angled triangle, you can use that one. If we're asked for an angle like this, remember, it's going to be trigonometry, or SOHCAHTOA for right angled trigonometry. If you remember how to do that. And remember, if it's an angle, we always do shift cos or shift sine or shift tan as the last step to get us back to what the angle was. It's really the inverse, but on your calculator it's shift. Okay, so if we've got one side in an angle with a right angled triangle, we're going to be using SOHCAHTOA, right angled trigonometry. But once we've got two sides, it's probably easier just to use Pythagoras' theorem. I hope that helps explain those questions. As I said, question 8 was another Pythagoras one, but I think having gone through those two, you should be able to do that one as well. Have a great day.